Hi everyone, so in this video what we are going to be talking about are the domain and range of a function. We briefly talked about that on day 1, but today we are going to dive into that a little further, and next class we will as well. So just to start off, a reminder of the definition of a function. A function is a relation that assigns each x value in the domain to exactly one y value in the range. Remember, this exactly one y value is a huge piece of determining if something is a function or not. Remember our vertical line test and all those good things. So exactly one y value is huge and critical in this definition. Remember, the domain is just the set of all x values for the function, or the input. You'll see it with domain, x value, or input. And range is the set of all y values or outputs for the function. Okay, so today we are going to go through the 3 different types of representations. We're going to look at tables, the potato diagrams, and ordered pairs. And then next class, so Thursday or Wednesday, depending if you're one of my red or white day students, then we will look at graphs. Graphs are a little trickier, but promise we're going to get through it. Alright, so the first example, we are wanting to find the domain and range of this table. And so, y'all know I love my colors, so I am just going to color code like crazy for these examples, okay? So, my domain, I'm going to make pink, and I know my domain are going to be all of my x values. So that is just everything on this side of the table. The most important thing when you're writing your domain and range is we're going to write them in set notation. Okay, so set notations when we have our little squiggly brackets, right? And when we write it out, we need to put our numbers in order from least to greatest. So sometimes they'll be given to you least to greatest, other times they will not. Okay, so that's just a little added step, but nothing you can't handle, right? So our domain, so all these x values, and we need to just put them in order. So we're going to start with that -1. Next is 2. Then 5, 6, and 8. Okay, this is like one of those math grammar things that I've always talked about. How I'm super annoying about math grammar. This is it, right? Is listing these numbers from least to greatest. Up next is we want to find our range. And our range are our y values. So that's this side of the table. And again, just like our domain, these need to be written in order from least to greatest. So we have -2, 4, 10, 12, and 16. If you wanted, what you could do, if you had like a ton of numbers, you're never gonna have like a ton of numbers this year. But if you did have a bunch, you could like cross them off as you went, just so you know you had written all of them down. Okay, so that is for a table. Up next, we're going to look at our potato diagram, or our mapping diagram, whatever you want to call them. So again, we're going to keep with our colors. Our domain is going to be pink, and our domain is everything in this circle. Okay, so I guess really the first thing you want to do is you would want to double check that this is in fact a function that you could write the domain and range for. All of these examples I'll tell you right now are functions in this video, just for the sake of making this straightforward. But that would be a good first step, is just to double check that yes, this is actually a function. Remember, if we did have a second line coming from any of these x values, so any of these values in our domain going to a second value in our range, you can think of the cheating analogy we talked about in class. That would tell us that this is not a function. But so none of these x's are going to multiple y values, so we are good to go. And we'll write our domain. This is already written least to greatest for us, which is awesome, so we're just going to copy that down. It is just 1, 2, 3, 4. That's our domain. Now it's time for our range. Okay. Our range, again, is also already in order for us. It is 10, 20, 30, 40. Okay. These are pretty straightforward. The biggest thing is just making sure you do have all of those numbers and you have them, you're writing them in order. All right. Up next, we have our ordered pairs. This is where it's a little trickier. It's not as just like straightforward as the potato diagrams where you just circled one of the potatoes or a table where we just highlighted an entire column. This we actually have to go like piece by piece. So I'm just going to highlight all of my x values in each ordered pair. So we have the -5, -2, 0, 2, and 5. I'm going to write those down for our domain. -5, -2, 0, 2, 5. And up next we have our range. 25, 4, 0, 4, 25. So what's different with this example than what we've seen previously is we actually have values repeating in our range. We do not have to write them multiple times. Okay, we can just write this as 0, 4, and 25. Okay, because the way you can think of it is if we had our if we had a potato diagram, these numbers wouldn't be repeating on the right hand side, right? There would just be multiple arrows going to them. Okay, so we don't have to repeat them in our range. Okay, since it was just these 3 separate unique numbers, you can just write them just like that. Okay? We got a few more examples just so you see 2 of each. Okay? Alright, first up, we have our table, so our domain. We're going to highlight. Again, this is already written in order for us, which is awesome. -10, -6, 0, 6. And then our range we have in orange. In our set notation we have 0, 1/2, and just 1. Okay, again, since we see that those 1/2s are repeating, we do not have to write them multiple times. Okay. Up next we have another potato diagram. Remember, the official name is a mapping diagram. So we have our domain here in pink. We're going to write these from least to greatest. -3, -2, -1, 0, and 1. Our range we have in orange. And this is what I was talking about earlier, where why we don't have to rewrite our numbers a million times is because in our potato diagram, the 9 and the 4, they're not written multiple times. So it's okay to just have them written once. So we're going to again put these from least to greatest. We go 4, 5, 9. That is going to be our range. Something important to remember, as I mentioned earlier, let me grab a pencil. Always be checking that this is in fact a function. If we had something going on like this, this would not be a function, right? Because this 1, as I told my white day classes, this 1 is cheating on the 4 and the 5, right? It's committed to both of them. Well, kind of, right? So you need every x value to be committed to exactly one y value. Like this -3 only goes to the 9. -2 only goes to the 4. -1 only goes to the 9. 0 only goes to the 5. But this 1 over here, it's cheating. It's going to both. It's in a relationship with both. And that is not cool. Okay? So remember that first up. Always make sure that you do, in fact, have a function before you write out your domain and range. Okay, so I'm just erase that so you don't see that later and get confused. Okay. Last example of an ordered pair. Again, doing our color coding. And then our range. Remember that first question we always want to ask ourselves, is this a function? And the answer, that's going to be no. If we look at this, we have this 9 is repeated twice, right? This x value is going to 2 and to 1. That is not okay. That 9 is cheating. And so, no, this is not a function. Okay, 9 goes to 2 and 1. Like I said, make sure you always check that. If I'm being honest, when I first wrote this example, I thought I wrote it as a function, so it's a good thing that as I was going through it, I was thinking, all right, let's double check that these are all in fact functions, because this one is not. All right, the last thing that we're going to do, and this is something that you guys will do in class, or I guess in class, but what I want to do is you are just given a domain and a range, and I want you guys to come up with any type of setup. I'm going to represent all three. I'm going to do ordered pairs and a table and potato diagrams just so you can see all of them again. But for the assignment, you only have to pick one. Again, don't do anything with a graph because we are not working with graphs yet. Domain and range from a graph can be getting tricky. We will be talking about that next class. So my first representation, I'll do a potato diagram just because they are easy. Okay, so we have our x and our y. So we have -6, -3, 0, 2. Our range is just 3, 6, and 9. And now you can just connect these as your heart desires, as long as you are still keeping it a function. Okay, so you only have, each x value only goes to one y value. Okay, there's our potato diagram. I'll do our ordered pairs over here, or I mean our table, whoops. -6, -3, 0, 2. Now we can do 3, 9, 6, 6, whatever we want to do. Okay, and as you notice, this doesn't match, these aren't the same. That's okay. They're still functions, right? It's still fitting the rules of a function. And so the last representation are our ordered pairs. So we have -6, 0, -3, 9, 0, 0. Let's do, and then 2 is left, and we still have to use the, oops, 6. This is not an option. There's not a 0 in our range. I got excited. We're going to have to make that a 3. So we have to double check our color coding. Go back and make sure we actually used all of the correct numbers appropriately. -6, -3, 0, 2. Yep, we're good. -6, -3, 0, 2. Yep, we're good. -6, -3, 0, 2. Yep, we are good for our domain. Now our range. We have that 3, 6, 9, which is good. Again, we have 3, 6, 9, which is good. Oh, I goofed again on this one. I, for some reason, just really, really wanted to put 0 for my range. Let's do 6 for that one. This is why we double check our work, guys, right? We have 6, 9, 3, and 6. So after some editing, the ordered pairs are good to go. So that is it for domain and range. Hopefully this was straightforward. If you guys have any questions, please let me know.